Well, good morning, everybody. The next 2+ hours, we're going to talk about post-tension one-way slab and beam designs that are particular to long-span garages. Now, the concepts I'm going to discuss can be applied to any type of building. I'm just going to highlight long-span garages because they're very relatively simple structures, very light architecturally, so we don't have to go into any of those type of details. And they're used almost all over the United States. If you've ever gone to a large airport or you've gone to casinos in Las Vegas and stuff like that, long span garages are almost all over the place. They can park huge numbers of cars, typically 2,500 cars are not uncommon. They're very useful systems to use, and especially if you're new to post-tensioning design and you're just kind of dipping your big toe into this world. The nice thing about long span garages is they are a very known quantity. They've been done numerous times. It's a very mass-produced building. Not saying there's not engineering required, but a lot of times the answer has been done so many times before that it's challenging to screw up, especially when everybody else knows what the answer should be. So moving forward, we're going to cover a couple topics. Obviously, we're going to look at long span garages, where are they typically, how are they defined, go through a one-way PT slab design that would be used for these garages, go for the beam design, also go for the girder design, and then lastly talk about some construction issues that are unique to post-tensioning, or excuse me, are unique to long span garages with a post-tensioning aspect. This webinar for 2 hours is not long enough to cover obviously everything, so I'm going to try to highlight some of the more basic or standard concepts. And again, if you have a question on something more advanced or something I'm not covering, please write it down and I will get to it to the best if I can. Now, as I usually do, if you've ever attended one of my webinars before, I shamelessly push my book. Everything I'm going to discuss in this webinar is covered in our book. It's about 15 chapters. First half is introductory 101 post-tension concrete that is used at several colleges right now: UCLA, Cal Poly SLO, Cal State LA, and a couple others that I can't remember at the moment. If you really have no idea about post-tension concrete, those take you from the very, very basics to more of the advanced topics that we do in industry: podium design, garages, diaphragm design, slabs on ground for apartments and residential construction. So if this does pique your interest, you can get it through SK2 Ocean Associates or lulu.com. Hard copies or ebooks are available. So moving forward, long span garages. Basically, they are defined by relatively thin slabs supported by relatively deep beams. Now, typically you're talking about the benefit of these garages is that they create really large open spaces. Very easy for architectural layout of parking, usually large areas for driving, which obviously are very good for parking structures, especially if they're public. In addition, you can restripe, change, remove, add rooms, whatever you want, because basically you have plus or minus 60 feet of open space, and that gives you a lot of flexibility as the buildings around change or tenant improvements and stuff like that. You can modify the parking as needed. When you do more of a short span structure, a two-way flat plate, you have columns at roughly every 29 feet on center. Obviously you're not going to move columns. So those columns define your parking, define your structure. 60 foot of open space, there's a lot of blank slate to play with there. So a lot of times for the much bigger garages that have a lot of turnover or access a lot of people, the long span garages work really well. The PT slabs are one-way systems. You're not a two-way slab, so we'll go through that design. Now, typically the slabs are between 5 to 8 inches thick, and they will span between 18 to 30 feet. Now, this system changes regionally. In the West Coast, where I'm located, typically these systems are a 5-inch slab and beams at plus or minus 18 feet on center. There's other areas in the Midwest and other contractor/engineers groups that do a much longer system in the 7 to 8 inch range. Their slabs will go on the 27 foot plus or minus range with a little slightly larger beam to span those things. And again, as I mentioned previously, these are very contractor-driven structures. As you see in the photographs later, the contractors have kind of developed their beam forms, developed these systems, and there's a lot of contractors that specialize in these garages. They have these things really squeezed down to the penny in terms of what slab thickness will work, what rebar will work, and they have their very, very particular systems. And so a lot of times you as the engineer are not defining the beam depth or defining the beam width per se. If you're teamed up with contractor X, most likely they have their own forms, they have their own beam systems, and they're going to tell you what they want to use, and you design accordingly for that.